Hello, students, boys and girls. I hope you're doing excellently well and you are enjoying your journey towards the destination of metals and non-metals. Yes, so you must have practiced all the reactions. Wonderful, very good. So now we will start with a very different topic known as metallurgy. Now, metallurgy is, what is metallurgy? Metallurgy is the study of extraction of metals from their ores. So we are going to study the extraction of metals from the ores. From the ores, how do we get the metals? What are the various steps? So that is what we are going to study now. Okay, great. So let's begin. Now, before we go to the extraction of metals, we should first know what is the difference between a mineral and an ore. Most of the time, students think that they both are the same. No, there is a slight difference between minerals and ores. So, minerals are the inorganic substances which are present in the Earth's crust. Okay, we have the Earth's crust, and then in that we have all these minerals which are present. Now, what is an ore? An ore is a mineral. Ore is also a mineral, but ore is a mineral. Ore is a mineral, number one. But what type of mineral is it? Ore is a mineral from which the metal can be extracted. Okay, easily and profitably. Very important. Okay, so there are two things whenever industrialists or factory people, they want to get or extract metals. What do they look for? They look for what is the ore from which we can get the metal easily, number one, and second, profitably also. That means because they're having a factory, because they are going to do the metallurgy processes, or the entire steps will be carried out for that metal, and finally the metal will be sold. So for that, what do? They see that from which ore can they get. Now all these ores are minerals, so from which mineral or the ore can they get the metal very easily and profitably, how they can extract it easily and profitably. So all ores are minerals. All ores are minerals. Okay, but all minerals are not ores. Got it? All the ores will be minerals, but all minerals will not be ores. So ores are those minerals from which the metal can be extracted easily and profitably. Two things, easily and profitably. So let's see the minerals. Minerals are naturally occurring substances present in the Earth's crust. Magnetite is a mineral. Hematite is a mineral. But magnetite is a mineral of iron, but it is not an ore. Because magnetite is Fe3O4. From this magnetite, we cannot get, or we cannot extract, let's start using this term, extract iron easily and profitably. Okay, easily and profitably. So it is just a mineral. But hematite is Fe2O3. This is an ore of iron, because from hematite we can extract iron easily and profitably. Got it? So hematite is an ore of iron. Magnetite is a mineral. Hematite is also a mineral, but it is an ore. Ore because we can extract iron easily and profitably from hematite. So that is the difference between mineral and ore. Minerals are inorganic substances which are present in the earth's crust. And ores are minerals from which the metal can be extracted easily and profitably. So we have seen an example. Magnetite is a mineral of iron. Hematite is also a mineral of iron. But out of the two, which is the ore? Hematite is the ore. Okay. Yes. Now we will see what are the steps in the extraction. First, we'll see what are the types of minerals. Now, these are the minerals. If you see in the picture, you see a number of minerals. Yes. So, extraction of metals. Now, let us see the types of ores first. There can be 4 types of ores, depending on what is the composition of these ores. We can have 4 types of ores. Oxide ores, that means they will have oxide anion. Carbonate ores will have CO3 2 minus anion. Then sulfide ores will have S2 minus anion. Halide ores will have Cl minus as the anion. So there are 4 types of ores. Oxide ores, carbonate ores which have CO3 2 minus as the anion. Then you have sulfide ores. Then you have halide ores. 4 types of ores. Oxides, carbonate ores, sulfide ores. Okay. And we have halide ores. Fine. So now the oxide ores type. Let's see what are the various oxide ores. Oxide ores would be aluminium is bauxite. Bauxite is Al2O3 dot 2H2. Then copper oxide, cuprites, Cu2O. Then iron, we have seen hematite, Fe2O3. Okay, this 3 is here. Hematite. Then we have tin. Tin ore is SnO2. Stannite. It is also called casterite. So these are the ores of the metals with their oxides. So we can get aluminium from bauxite. This is known as bauxite ore. Okay. And this is the formula. Cuprites, Cu2O. Iron, hematite, we have seen Fe2O3. And then tin, SnO2. So if you see, all of them have this anion. So it is an oxide ore. Then coming to carbonate ores. Carbonate ores are from which we can get calcium is limestone. You all are familiar with this limestone, calcium carbonate. Then zinc carbonate, calamine it is called. Then siderite, FeCO3. And then we have zinc blend again. Okay. So calcium, zinc and iron. Here we have the carbonate ores. Their anions are carbonates, and we can extract the metal from these carbonate ores. Then we have the sulfide ores is zinc sulfide and copper glans, Cu2S. Copper glans it is called. So you can remember at least 2 examples for each type of ore. Then we have halide ores. Now halide ores are lead. Lead is also sulfide ore. PBS. Galena. It is called galena. Now we come to the halide ores are mercury, sodium, then fluorspar and silver. This is fluorine. Fluorine. Okay. So for fluorine, we take calcium fluoride and then we can, and we have silver is silver chloride. These are the halide ores. They are called mercury, sodium, fluoride or fluorine ore, which is fluorspar, and then silver. On silver, it is called silver chloride. So these are the 4 types of ore. What are the 4 types of ore? We have the oxide ore, the carbonate ore, then the sulfide ore, and the halide ores. That means their anions are oxides, carbonates, sulfides, and chlorides. And the metals can be extracted from these ores. Okay, you can remember at least 2 examples for each. So what have you learned till now? We have learned about what is a mineral. A mineral is an inorganic substance present in the earth's crust. Then ore. Ore is a mineral from which the metal can be extracted. From which a metal, yes, can be extracted. Can be, you have to use this word, students, extracted. Instead of using obtained, we can get and all. No, this is the right word, extracted easily and profitably. 2 things here. One is easily. Second is profitably. Right? So easily and profitably, it is called an ore. So we can say that all ores are minerals. We can put it as all ores are minerals, but all minerals are not ores. Got it? So this is how it is. Then we have done about types of ore. Types of ores, there can be 4 types of ores. We have done about oxide ores. Oxide ores will have O2 minus. So if we take bauxite, Al2O3.2H2, generally they may ask you for the, what is the formula for bauxite? It's a very known ore. Okay, bauxite, then hematite. So you should know these names also. Okay, hematite is iron ore, Fe2O3. It's an oxide ore. Then the second category of ores is the carbonate ores. Carbonate ores will have CO3 2 minus. Example, zinc carbonate. Then you have iron carbonate also, but mostly hematite is used for extraction. Then you have the sulfide ores. Sulfide ores will have S2 minus. Yes, so you have here zinc sulfide, or you have Cu2s. Okay, so these are the sulfide ores. Then you have halide ores. So they have the halides, either chloride or fluorides. So you have sodium chloride. Then you have fluorospar, CAF is fluorospar, where you have the fluorine or the fluoride as the halide. Okay, so these are the types of ores. You can remember at least 2 examples for each. You should know what is the anion in each of them. Right? So this is what you've learned till now. I hope you will enjoy metallurgy a lot. And of course, we will again have a few reactions in metallurgy also, but more important would be the steps for the extraction. So we will be doing it very, very soon. We will continue with the topic. Until then, this is Usha Mangipudi signing off.